Hi guys, good afternoon. So in the last session, we saw about the fully specified static route. Okay, and then we saw about host route, and we had a bit of introduction about the app timeout also. Okay, now, so far we have covered in the static routing about your recursive static route. Okay, we have covered the recursive static route. We have covered the directly connected static route, then fully specified and host route. Now the next one is about floating static route. So understand this one. Now, anybody would like to tell me what is the floating static route? Yes, guys, anyone? No one?
This backup route.
It's kind of a backup route, right? So we can say a floating static route. Yes, Balakumar.
Sir, it make a router primary or secondary.
Sorry.
Actually, to make a router primary or secondary.
Yes, we can say that also. So a floating static route can be used to provide, we can say, redundancy to a route. Okay. So it can be used to provide a redundancy to a route. That means basically kind of a backup route. So a floating static route works as a backup route, or you can say secondary route. It will be added to the routing table. Okay. Your floating static route will be added to the routing table if the primary route goes down. If your primary route is down, in that case, your floating static route will be used. Okay. So here also we can kind of consider the same scenario. If I take this same scenario, so if I consider this scenario here, so here we can say that if we talk about R1, so R1 has two possible ways to reach the 10 network. One is directly via R3 and another one is via R2. Okay, these are the two possible ways to reach the 10 network. Correct? Now, the thing is, if we see here, let's say if I configure two static routes here. Okay, so how these routes will appear in my routing table? If I configure these two routes on R1, so in R1's routing table, like I'll be using two comments on the R1. Okay. On R1, I'll be using two comments. One is IP route. Then I'll say, let's consider the interfaces. 0. So consider this is the 0 by 0 interface. And this is here Z0 by 1 interface. Again, Z0 by 0 interface. This is Z0 by 1 interface. This one, let's say Z0 by 0. This one, Z0 by 1. Okay. Now what? Like I said, on R1, we have to execute the comments. So if I go and execute the comments like this on R1, that in the global configuration mode, I can say IP route, and I want to reach the 10.1.1.0 network, 255.255.255.0. Then my exit interface will be, let's say this is my best route. So my exit interface will be Z0 by 0. And what will be my next stop in this case? What will be my next stop?
192.168.13.3.
Exactly. This will be the 13.3, right? So I'll say 192.168.13.3. Okay. Then second route, if I configure 10.1.1.0, 255.255.255.0, Z0 by 1, what will be my next stop in this case?
12.2.
12.2, right? So this will be 192.168.12.2. So I have a question here. Do I have a redundancy here?
Yes, sir. Yes.
Everybody agrees that I have a redundancy?
Yes, sir.
Okay. So if you say I have a redundancy, okay, that means if one of my route goes down, my second route will forward the traffic, correct? I
Yes.
have a redundancy. And what else I have here? I have like one is you say that, okay, in this case, I have redundancy. And second thing, what will happen here? Like in my routing table, if I see how these routes will look like. So my routing code will be S. My route code will be S. And then it will be given as 10.1.1.0/24. Okay. Then via Z0 by 0. This will be one entry, and second entry will be 1 by 0 via Z0 by 1. This will be 13.3. And this will be like this. This is how the route will be there present in my routing table. Now, in this case, what is happening? That both the routes are present in my routing table. And since both the routes are present in my routing table, what is going to happen here?
Load balance.
Exactly. My router R1 will start load balancing. My router R1 will start doing what? It will start doing load balancing. So what do you understand with load balancing?
Some packets will go through R3 and some will go through R2.
Correct. So some packets will travel via the next hop 13.3 and some packets will travel via the next hop 12.2. Okay. Now you say that I have some redundancy. Okay. Yes, I have a redundancy that if one of the link goes down, one of the route goes down, my traffic will be forwarded. But when my link is not down, okay, I'm considering a situation that my actual, this link is not down, okay, this link is not down, only the communication, maybe it has a high latency, okay, the communication is not down, but what do we have here? We have here high latency. We have here high latency, okay, or maybe this particular link, right, like this link is okay, this link is okay, but here this link is down. So is it going to affect my route in the route R1?
No.
No.
Sir.
Again, both the routes will be present in my routing table.
Yes, sir.
And if both the routes will be present in my routing table, half of my traffic will pass and reach the destination, and half of my traffic will not reach the destination. Do I have proper communication here?
No.
No. We do not have proper communication. And in this scenario itself, imagine what if this also goes down? Your backup route is present in the routing table. In your routing table, it will show that, okay, this is the route, but still you will not have the communication, right? You're not going to have the communication. So again, here also we do have some problem, right? So to avoid this scenario only, what do we have? Like to avoid this load balancing kind of situations, we have the floating, because this might be like in my organization, again, there is a possibility that I have taken two internet connection. Okay, this is my internet connection, which is, let's say, for example, having 100 Mbps of speed. And this is my backup ISP connection, which is only 10 Mbps, right? Now I don't want that, okay, my traffic should pass via 10 Mbps. Getting it?
Yes.
Yes.
Right. So to avoid this kind of scenario that I don't want load balancing here. Okay, I don't want the load balancing here. So if you don't want load balancing, in that case, we can use the floating static. That whenever my primary route or my primary ISP is working, I will always forward my traffic through the primary ISP. And when my primary ISP is down, in that case, my traffic should pass via the secondary ISP. Is that clear?
Yes, sir.
Okay.
Sir, the primary ISP is down. In that case, that primary ISP route is present in the routing table or not?
No, that will not be present. As soon as this particular link is down, okay, so the route will be removed from the routing table because this is
Oh.
directly connected. But if it is not directly connected, let's say in case of secondary ISP, okay, consider this is the best route. Okay, in that case, if this side is affected, in that case, your route will not be removed from the routing table, only if it is directly connected.
Okay.
Okay, there is a problem with the static route. That's why later on, you will study about IPSLA also.
Okay.
Okay.
Direct connected only. That is removed. Another one not removed, right?
Yeah. Otherwise, it will not be removed.
Okay.
Okay. So to avoid this kind of issues, we go with the floating static route. And how do you configure floating static route?
By changing administrative distance.
By changing the administrative distance, correct. So we will say IP route. You will say your network ID, subnet mask. And then you will give the exit interface. Okay. After the exit interface, you will have next stop address. And then you will have your AD. Whatever the new AD value you want to assign here, that ID value will be there. Okay, so this is how you're going to configure the floating static route. Okay. Now we will practically see this. Okay. So let me start the lab. Let's start the image. Host route, static routing, null. This. Loading static route. Okay, so again, here I'll take around 4 routers. R1, R2, R3. Okay, R4. We'll just keep few loopbacks only here, okay? Okay. So Z0 by 0 connected to Z0 by 0. Then here Z0 by 1 connected to Z0 by 0. And 0 by 1 connected to 0 by 1. Okay. Start all the nodes. So we will have one loopback on the R1 slash 24 will be the mask, or let's use slash 32 this time. Totally fine. Okay. And here we will use few loopbacks. 3.3.3.3. Let's say 33.3.3. Okay, let's say these two loopbacks are there. And then here we will be using the network. (13.0/24). This will be 13.1. This will be 13.3. This will be 12.1. This will be 12.2. This will be 23.2. Then this will be 23.3. Okay. Here we will use 12.0/24. And here we will use 23.0/24. Okay. And this is for floating static route. Floating static route. Okay. Now who is willing to do the configuration?
May I, sir?
Okay. So let me give you the access. Hmm.
Sir, can I take one photo for a topology?
Sorry. Yeah.
I want to take
Yes.
one
Yes.
photo.
You can do it.
Done, sir.
Done. Okay. So you can start with the R1 configuration. Guys, who wants to do the R2 configuration? Two people for R2 and R3. Okay, Abdul for R2. For R3? Okay, Gagan. All right. Okay, Urvish, you can control the screen now.
Host name also you can change.
Loopback interface /32. Done, sir.
Okay. Now, number 2 for who was there? Abdul, right?
Okay, sir.
Okay. Okay, Abdul, now you can do it.
Done, sir.
Okay, then for R3, Gagan,
Me, sir.
yes. Okay, please start.
Loop back one should be 3.3.3.
Guys, you people can also help him, right? If something goes wrong.
Yeah, gigabit 0 per 0. You need to go to gigabit 0 per 0, not gigabit 0 per 1.
Also, the loopback one should be 3.3.3.3.
All okay? Or still something is wrong?
Loopback 2 should have global subnet mask.
Yeah, correct. Check the configuration of loopback to interface in the running config.
Include or section. Last. You're in interface mode.
You can use the command, right? Show running config interface and interface name. No need to use any include or pipe. Okay, this is loopback 1. What about loopback 2? Check the subnet mask. It is /32, right?
Yes.
Done. Okay, now. So the lab is configured and we can verify. Show IP interface brief. 13.1, 12.1, and then 1.1, all good. Show IP interface brief. 12.2, 23.2. Show IP interface brief. So 13.3, 23.3, 3.3, and 33.3. Okay. So now see here. Again, our requirement will be what? We will configure this route as a best route and this second route as a backup route or floating static route. Okay. So how we are going to configure it? The command we have already seen here, that you can use the command IP route network subnet mask exit interface next stop address, and then you can give the new ID. Okay. So initially what I'll do is I'll just go and configure both the routes without any AD value. Okay. So let's go on R1 and I'll say configuration terminal. Then I'll say IP route and I'll configure it for, let's say, 3.3.3.3 255 255 exit interface Z0 by 0. Next stop address will be 13.3. Okay. And same route I will also configure via 12.2. And then I'll say 33. And then I'll say 33. Routes are configured here. Okay. Now if I check do show IP route static. So you can see what is going to happen right now. You can see I have route, so I'll have communication, right? Yes or no? So if I try to ping right now, if I say do ping and 3.3.3.3, will I have communication?
Yes.
Yes, sir.
Yes, sir.
What will be my success rate?
Uh,
80.
80%.
80%. How many of you agree? Everybody agrees? Okay. But this will not be 80%. You see here,
Yes.
my success rate is
100%.
100%. Okay.
but sir, we are doing first time, no? We are doing ping for first time.
Yes, but we have provided next stop address. And whenever you add a route, next stop reachability is checked. Right? Next stop reachability is checked. So when checking the next stop reachability, the MAC address will already arrive. Okay.
Yes.
Try again. See, 100%. If I check how the traffic is going, trace route 3.3.3.3. Do you see I don't have a proper response here? So one time fail, second time 13.3. So why this one time fail? Because R2 doesn't have the route, right? For 3 and 33. So if I go and
Yes,
configure
yes.
here, configure terminal, okay, and if I say IP route 3.3.3.3, interface will be Z0 by 1. Next stop will be 23.3. Okay, and same thing for 33 also. Okay, and for complete communication, I want that, okay, this 3.3, that means R3 also should have the route for 12.0. So one route I'll configure here. IP route 192.168.12.0, 255.255.255, 0, interface Z0 by 1, and next stop address is 23.2. Right? Now check again. Now we will have full connectivity. And if I trace, you will get the trace route also. So what you're going to see here, that one packet will pass through 12.2 and second packet will pass through 13.3 like this. See, 13.3 it is going. One traffic going there, 13.3. Now second traffic. Wait a minute. Why it's not going. Z0 by 0, 12.2, 12.1. Are the IPs okay? Do show IP interface brief. Z0 by 1 is 12.1 and 13. Looping 1 by 2, 16, 12.2. Here we have the connectivity. Do ping, okay. So I need a route, no need. Do ping 3.3.3.3. I have the communication. 33, I have the communication. Everything is good. Let's trace again. Going where? 13.3. This is strange. Technically, it should load balance. Do show IP route static routes. Okay. The exit interface is the problem. Okay. Do show run pipe section IP route. Exit interface is not correctly mentioned. That is the issue. Okay. So this comment, I'll say no. And then we will say this is leak0/1. And for this one, 33. And the next stop is 13.3. No, 12.2 only. And this has to go via Let's check again. Now all the routing is okay. Okay, so you can see that the one going via 13.3 exit interface is 0 by 0. The one going via 12.2 exit interface is Z0 by 1. Again, 0 by 0, 0 by 1. So now we should see proper load balancing. Now this is okay. So if I check do ping 3.3.3.3, I have it. And if I trace route, okay, so this time we will see that the packets will pass through 0 by 0 and 0 by 1. Still the same. 12.2 0 by 1. Okay, one more time we will trace. Okay.
Sir,
Mm-hmm.
so for 12.2 and 13.3, the interface मतलब G0 by 0 ही है, दोनों same ही है.
No. For going 12.2, when we are going to 12.2, we are using Z0 by 1 interface. When we are going to 13.3, we are using Z0 by 0 interface. The exit
Okay.
interface is on the router where we are configuring the route.
Oh.
Okay. Yeah. Okay. Let me do one thing. What I'll do is I'll just shut down this Z0 by 0 interface. Then we will see what is the issue. Interface gig 0/0 shutdown. Now, if we check do show IP route static. So we have only one path. Do ping. We have the communication. Base route 3.3.3.3. Okay. Now I see what was the issue. When we were trying to send the packets, right? Earlier, the wrong configuration, right? The configuration earlier was incorrect interface, right? So when the app was done, maybe this guy acted as a proxy. That was the issue. Now, one time we have shutdown and no shutdown. Now it will be all good. So if I say interface gig 0/0 and no shutdown, let it come up. Do show IP routes static. All good. First of all, check the connectivity. Okay, connectivity is there. Let's trace route. Now you can see that the first traffic is going via 12.2, second traffic is going via 13.3. Okay, then again 12.2. Is it clear? So now you can see that they are switching between the traffics. Now last one went through 12.2. So this one will first go via 13.3. Okay, so this one you can see last one was, so like it's happening on per packet basis, like one packet here, one packet here, then again one packet here, then again one packet here, like this. Okay. Now what I want that, okay, load balancing should not be there. Okay, what I need is what? That my old traffic should pass via 13.3. So what I can do is, whatever the routes are going via 12.2, those routes I will increase the AD. So first I'll say no. Then I'll increase AD, like let's say, for example, 5. Then I'll remove the 33 also. And then this will be 33. So now if I check in my routing table, first of all, let's check in the running config. So you can see I have increased the AD of 12.2 side. Okay, so now these two routes, they will never be present in my routing table. They will not be seen in the routing table. My routing table have only one route, which is going via 13.3. Okay. Now what? If we check the traffic, first of all, communication. So communication will be there. If I say do ping 3.3.3.3, so communication is there. And if I trace route, so trace route will go via 13.3. Okay, because my primary ISP is available. And if I shut down this interface gig 0/0, shut down. So earlier my routing table was having the route which was going via 13.3. And now if I check, do show IP route, or if I check only static, so you can see now my AD value is 5 and the route is going via 12.2. It's not going via 13.3. Earlier it was going via 13.3. Here AD value is 1 and here AD value is 5. This is clear?
Yes.
Yes, sir.
All right. So this is your floating static route. Then after floating static, we have default route and null route. So first let's go with the null route. Now null route means, so this route is used to prevent a loop. Used to prevent a loop. Okay. So if you take example of 3 routers, we have R1, we have R2, okay, and we have R3. And they are connected. Okay. So now what will happen? That let's say on this side you have one of the loopback 172.16 something like 1.1. Okay, this kind of network is there, like /24. This kind of network is there. So say this is R1, R2, R3. Okay, and you can consider that this is ISP. Okay, this is my edge router. So basically what I'm trying to say is here that let's say this ISP has a route something like 172.16.0.0/16. Okay, 172.16.0.0/16. But here we have the network only 1.0/24. And on R2 and R3, we have default route towards the ISP. So what will happen? Whenever there will be a traffic, okay, whenever there will be a traffic for 1.0, the traffic will pass via like this only. Okay, from R1 to R2, R2 to R3. Okay, like this, the traffic will pass. But what will happen? Let's say, rather than 3, let me take example of only 2 routers. That will be easier for explaining. Okay, take example of 2 routers. Otherwise, it will create confusion. Say this is ISP. And this is my edge router. Okay. And here on my inside network, I have one of the public network, let's say 172.15.1.1, let's say, for example, 1.0/24. That means I'm just taking an example only. Now what? The ISP has a route, something like 0.0/16. Okay. So now what will happen? That I have a default route on the edge towards this side. Now, if on the internet, if there is any traffic for, let's say, IP 15 dot something, 172.15 dot, let's say 1.pi, which is available on my internal. So ISP will forward it to my edge router, and my edge router will provide the communication, no issues. But instead of this, if the traffic came for 2.5, so what will happen? ISP will forward it to my edge router, and my edge router will forward back to ISP. ISP will again forward back to edge router. Edge router will again forward back to ISP. I hope you're getting the point.
Sorry, come again, sir.
Sorry.
Sir, that IP should be 15.2 or 16.2?
Yes, 15. This example, right? Okay, and this is also 15. Okay, and this is also 15. /16. Okay, this is a route that is towards my edge. And this is a default. Okay. So now you can understand that the loop will be created
Yes, sir.
because ISP will forward to the edge will forward to the ISP. So what we will do on our edge router, we will configure one route. We will say something like if there is any traffic, okay. Any traffic for this network /16. So I'll configure it for like exit interface we will give, right? So exit interface, I'll give the null zero interface. Okay. So any traffic that is going to null zero interface, that will be, discarded basically. That will be discarded. Okay. Understood? So configuring is very simple. You can say IP route network subnet mask. Okay. And then here you will give the null zero. Is it clear? So that means basically same like, how you configure directly connected static route. Okay. Is it clear?
Yes.
So do I need to show this thing practically or you will do it?
So we'll try.
Okay. So same topology you can try, right? You can take two routers. Here you can configure one route for 172.15.0.0/16, and here you can configure 1.0/24 network. Okay, and in between these two, you can configure like you can say 12.0/24. This is something you can configure. Here you can configure .1. Okay, and here you can configure .2. Okay, and this will be done once you configure null zero. So when you configure it, you might face a problem because this will cause a loop. Yes, Abdul.
Sir, this 15.2.5
Mhm.
IP address is part of this 15.0.0/16, right?
Mhm.
I'm asking.
Yes. I'm not configuring this network on the ISP, right?
Yes.
On the ISP, we are configuring this network 12.0/24.
Mhm.
Okay.
Okay.
So according to the route, ISP will forward it to the edge and edge will forward it back to the ISP. So this will create a loop. So your routers might stop responding or they might work slowly. Okay. All right. So you can try this. Then last one in the static routing, which is about default route. Okay. So everybody understand default route? A default static route is used to forward the traffic to a specific next hop configured. Okay. Irrespective of the destination network. Okay. So when a more specific network is not available, always your default route will be used for forwarding the traffic. So you can say when a more specific network is not available, in the routing table, the router will forward the traffic. When a more specific network is not available in the routing table, the router will forward the traffic using the default route. Okay. And how do you configure it? So you say IP route, network is unknown, mask is also anything. And here you'll give the exit interface. And then you'll give what? Next stop. Okay. So this is how you will configure a default route. So example topology you can take. So again, two routers only, R1, R2. R1. And then this is R2. Here you will use the network 192.168, 12.0/24. Okay, here you will configure .1 IP. Here you will configure .2 IP. And here you will configure few loopbacks, maybe 10.2.2.2/32, 20.2.2.2/32, 30.2.2.2/32, 40.2.2.2/32. These are the loopbacks you will configure. Now R1 has only one single path to reach all these networks. So what you'll do, you'll configure a default route on R1. Clear? Yes or no?
I see. Sir, will you please scroll up a little bit?
Sorry,
Will you please scroll up a little bit?
now?
Down. That last apology.
Okay,
I
last.
want to take a picture. Yes.
This paint file will be updated in your drive, right? Immediately.
Okay. Sir. Thank you.
Okay. So these two are a task for you, okay? And from tomorrow's session, we will start with the dynamic routing. Okay. So before starting with the dynamic routing, you guys are to prepare with the advantage and disadvantage of static route. Okay. So don't tell me the CCNA ones. Try to dig deeper that, okay, what are the advantages? What are the disadvantages? Okay.
Yes.
Yeah. So these two you complete today, and tomorrow we'll first discuss about advantage, disadvantage of static, and then we will start the dynamic routing. Okay. Okay, guys, then that's it for the day. Okay, tomorrow we'll start with the dynamic. Any doubts?
Okay, sir. Thank you.
No?
Sir, I have a doubt. When the normal route is generated, when the proxy route, proxy ARP is generated, normal ARP and proxy ARP.
Proxy ARP will be generated when your router is working as a host.
Okay.
Okay, when your router is generating the traffic, in that case, let's say router is generating a traffic for a node which is not available in the same network. And again, that will also depend on what kind of route is used. Let's say if you have used recursive static route, in that case, okay, two scenarios are there when proxy ARP will be generated. Number one, like when proxy ARP will happen, number one, a router working as host. Number two, a router using directly connected static route. In these two cases, proxy ARP will be there. Remaining all the cases, normal ARP.
Okay, sir.
Okay. Yeah. And you have to make sure the traffic is getting generated from the router only.
Okay. In the same network, I think mostly normal ARP, right?
Normal ARP. Same network, never proxy ARP.
Okay. Different ARP, different network, proxy ARP is there, right?
Yes.
Okay.
Destination is in different network. Okay.
Okay, sir. Thank you.
Yeah. All right. Okay, guys, then I'll see you tomorrow. Have a good day.
Sir, I didn't get access.
You didn't get access. Let me check. Let me stop the recording first.